Hi, I'm Megan Wyatt. I'm a senior in the Honors College, and my thesis is on comparative dental morphology of mice.
What inspired your thesis?
So my thesis is actually a culmination of a lot of different inspirations. So one thing that I've learned as a paleontologist is that there's a really kind of big issue with paleontology where you're learning about the biology of these animals, but you don't necessarily have any genetics to be able to say how are these things related. So something that we always struggle with is when we say, we know these two things are different because the genetics tell us they're different, but the bones are telling us that they actually are really similar. And so my thesis is trying to get at how do we kind of deal with that kind of morphological similarity and actually try to quantify morphology and to say, we know that they're different, and so let's try to find a specific difference that we can use to identify them and separate them. And what's really interesting is that rodents actually encompass 40% of all mammal diversity, but they're one of the least studied groups in the fossil record. So that's another thing that inspired my thesis to say, we need to know more about these things, and so why not study them more?
What is teeth morphology?
So morphology in general is just trying to say how are shapes different. So for fossils, we try to say, we have these bones and how do we compare one bone to another bone, and we call that morphology, is trying to describe how they're shaped differently. So for tooth morphology, that would mean like how does the enamel shape change? Do they have a certain number of cusps? And a cusp, if you like kind of feel your molars, it's kind of the sharp bits on your molars. That's what we call a cusp. So we can use all these kind of words to actually try to describe how things are different. So that's what I'm doing with my thesis, is seeing how tooth morphology is different on things that kind of look the same. So trying to say, how are these teeth actually different in their shape?
Who's your favorite mouse, Mickey or Jerry?
I'm gonna have to go with Mickey. I've always loved Disney since I was really young, so I'm gonna go with Mickey. It's a special place in my heart.
If you were a mouse, what kind of cheese would you prefer?
I don't know if my taste buds would change a lot if I was a mouse, but I definitely have a soft spot for sharp cheddar, so I'd like to think my mouse self would also prefer that.
What would it mean to your field if you proved your thesis?
So proving that these two things can be distinguished based on teeth alone would actually mean a great deal. Because one of the reasons I chose this group in particular is because one part of this group actually doesn't have a fossil record that reaches back as far as we think it should. We estimate that these two groups diverged about 20 million years ago, but one of these groups only shows up in the fossil record about 1 million years ago, which is kind of a red flag for me to think that we've actually probably just misidentified them because we didn't have a good way to tell them apart. So what this means is that we actually could increase the diversity of this group in the fossil record if we have a clear and concise way to tell them apart, which I think is really exciting. Thanks for watching.